Okay, so let's create a point wrangle and let's call this hit near. The idea is based on each one of these points, we want to generate a second point nearby that's going to have some movement as well. Okay, so the logic behind this was that, let's create some normals. We were going to be getting for each one of the particles or each one of these points, we'll get the normal of the surface. And we have the surface here. Let's make sure that surface has point normals and let's input it on the second one. My reference point is something we use often as well. Reference point is going to be equal to the near point on the surface. I've input 1 and based on the current position. So we know the reference point. Let's grab that normal. Vector ref norm is going to be equal to the point on input 1. The attribute is normal and the point number is our ref pt. So we're grabbing the normal of our nearest point on that surface. And we can say that our points normal is going to be equal to the ref normal. This should allow us to see the first if the first step is working. And here we have the points and they're grabbing and they're updating the normals based on the area where they're at. So great, perfect. This is first step. Second step, we want a perpendicular vector to this. And here we're going to introduce some basic math, vector math. And we're going to be using the cross product. So let me try and make this a bit clearer. The cross product between two vectors says that if we have a vector and let's imagine we have another vector because we want a vector perpendicular to this one. So what's going to happen is if we just establish a temporary vector of pretty much any direction you want, we will get, with the cross product, we will get a vector, a third vector that's perpendicular to this one. It will actually be perpendicular to both of those vectors. If we then do the cross product of this one and this one, then we'll have something that's perpendicular to this. Okay. And this is what I'm going for. We have a normal. This will be the normal, and this will be our side vector. Nothing like doing it. So let's see. So the temp vector, which is going to be that temporary result that we get, temp vector, this is just a temporary step. It's going to be equal to the cross product between our normal, which is the one we're interested in, and some random vector. And usually we go with something just pointing up. And let's make this visible. I'm going to say that the side attribute, the vector side, is going to be equal to the temp vector for a moment. Now, one thing we need to consider is that we're interested in directions. The length of the cross product result isn't really interesting at this point. So we're going to be normalizing all of this. So let's normalize. We just want directions. So length of 1. Now we normalize it and we have this attribute. Let's have a look at that attribute. Control, middle mouse button, and let me see, temp v, side. Here it is, side. It's supposed to be visible. It's not. Right click, go to side, click here, and it needs to be a marker. It needs to be a vector, and the color doesn't really matter. It's fine. So now we have this temp v, and we have the vector side, and I really can't see it. And the reason for that is actually pretty obvious. You notice that I'm referencing something that hasn't been established yet, so I need to get the ref norm. Okay, my fault. Ref norm, this happens. Okay, now we have something. And it is, as you can see, it is perpendicular to that vector, okay? But if we have a look at if we have our mesh, it's perpendicular in a direction that's not really very interesting, okay? We want to have something that's perpendicular but tangent to the surface and not just perpendicular to that point. Okay, so we need something that's actually perpendicular to these two. We should have something going on, let's say, here, for instance, on the arm. We should have something either pointing on that way or that way. That's the way to go, okay? So that's what we're going to be doing, and the easy way to do that is just by creating another vector. That's going to be the actual side. It's going to be equal to the normalize cross product between those two, the ref norm and the temporary vector that we just calculated. And now, lo and behold, there's a typo, normalize, and we put here side, and we should have the direction that we're going for. Okay. Does this make sense? I hope it does. Okay, now we have something that's more tangent to the surface.